For most of human history, very few people lived long enough to grow old. The human brain was shaped in a world where intense emotion helped young adults survive danger, compete, bond, and reproduce. Strong fear, strong desire, strong anger. These were useful in short, uncertain lives. But today many people live far beyond 40, and something quiet often happens. The emotional highs are less extreme. The reactions are slower, softer. It can feel as if something has faded. If our ancestors were not built to spend decades in middle age, what happens to the emotional system after its original job is done? And why 60% of your emotions disappear after 40? For most of the 300,000 years that Homo sapiens have existed, reaching the age of 40 was not guaranteed. In many prehistoric populations, average life expectancy at birth was low, often because of infant mortality, infectious disease, injury, and unpredictable environments. This does not mean no one lived beyond 40, but it does mean that a large portion of the population never entered what we now call middle age. The emotional system of the human brain formed inside this demographic reality. It was shaped in small bands of hunter-gatherers moving across open landscapes, where survival depended on rapid decisions and strong internal signals. In that world, intense emotion was not a personality feature. It was biological guidance. Fear sharpened attention when a predator appeared on the horizon. Anger signaled boundary violation inside a tightly connected group. Desire pushed individuals to seek food, status, alliance, and reproduction before time ran out. When we speak about emotion, we are speaking about neural circuits that were selected in environments where life was often short and physically demanding. The brain did not evolve under the assumption that most people would spend decades managing long-term stability after raising children. It evolved to maximize survival and reproductive success in early adulthood. From an evolutionary perspective, the period between roughly 15 and 35 carried the highest biological urgency. During those years, hormonal levels are at their peak. Dopamine activity, linked to motivation and reward, is generally higher in youth. Testosterone and estrogen are more active. The amygdala, a region involved in processing threat and emotional salience, reacts strongly to social and environmental signals. These systems make emotional experience feel vivid and immediate. They increase the likelihood of action. In a Paleolithic landscape, hesitation could mean starvation or exclusion from the group. Strong feeling was functional. It mobilized the body. It narrowed focus. It accelerated response. After 40, however, the evolutionary pressure changes. In ancestral settings, individuals who reached this age often shifted roles. They were less likely to be in direct competition for mates or status at the same intensity as younger adults. Their value increasingly came from accumulated knowledge, memory of seasonal patterns, understanding of social dynamics, and practical skill. The environment did not demand constant emotional peaks from them in the same way. Archaeological evidence of long-lived individuals with healed injuries suggests that older adults were cared for and contributed in non-competitive ways. In such a context, an emotional system that gradually becomes less reactive may not represent failure. It may reflect a recalibration. The phrase 60% of your emotions disappear after 40 is not a literal measurement. There is no scientific instrument that calculates emotional volume in percentages. What research does show is that many adults report reduced emotional volatility with age. Studies in lifespan psychology indicate that negative affect tends to decline across middle adulthood, while emotional regulation improves. Brain imaging research suggests that older adults often show lower amygdala reactivity to certain negative stimuli compared to younger adults. These findings do not imply that emotion vanishes. They suggest a shift in intensity, frequency, and regulation. When we look back toward the beginning of human history, this shift becomes less mysterious. A system designed for urgency does not need to remain in constant emergency mode once the primary reproductive and competitive phase has passed. In a species that rarely expected extended middle age, the gradual softening of emotional extremes may be an echo of an older biological script. The question is not whether emotion disappears, but whether its original purpose changes once survival is no longer the central daily threat. If we remain inside the environment where our species began, the structure of daily life helps explain why emotional intensity was concentrated in youth. A hunter-gatherer band usually consisted of a few dozen individuals. Social bonds were close, visible, and difficult to escape. Reputation was immediate. Conflict could not be ignored or postponed. In such a setting, emotional signals needed to be strong enough to guide fast behavioral adjustments. Fear prevented unnecessary risk. Jealousy guarded mating opportunities. Pride reinforced status within the group. These reactions were not random. They were adaptive responses shaped by repeated selection over thousands of generations. In a landscape without police, contracts, or long-term financial systems, internal emotional force was a primary regulator of behavior. The body itself reflects this urgency. During adolescence and early adulthood, stress hormones such as cortisol rise quickly in response to threat. Dopamine circuits in the mesolimbic pathway respond robustly to novelty and reward. This makes exploration and risk-taking more likely. From an evolutionary view, this pattern increases the chance of discovering resources and forming alliances. At the same time, reproductive hormones amplify emotional salience. Attraction feels urgent. Rejection feels overwhelming. Social exclusion can activate neural pain networks similar to physical injury. In small ancestral groups, exclusion could mean death. The emotional intensity of youth mirrors the high stakes of that environment. After 40, the biological landscape gradually changes. Hormonal levels tend to stabilize or decline. Testosterone decreases slowly in men. Estrogen fluctuates and eventually declines in women during midlife transitions. Dopamine receptor availability has been observed to reduce across adulthood, influencing how strongly rewards are experienced. These shifts are measurable in longitudinal studies. They are not moral judgments about aging. They are physiological patterns. When reward sensitivity lowers, emotional peaks often soften. When stress responses become less reactive, the amplitude of fear or anger may diminish. From the perspective of a brain shaped for short, demanding lives, this pattern is coherent. Once the phase of intense competition and reproduction has largely passed, constant high reactivity offers fewer advantages. Archaeological records show that individuals who survived into later adulthood often carried knowledge essential for group survival. Migration routes, medicinal plants, seasonal timing, their contribution relied less on rapid emotional mobilization and more on memory and stability. A calmer nervous system may have supported this role. It allowed observation instead of impulsive action. It favored deliberation over immediate response. This does not mean older adults lacked emotion. It means the function of emotion likely shifted from driving urgent survival behavior to supporting group cohesion and continuity. When modern people describe that a portion of their emotions feels as if it has disappeared after 40, they may be perceiving this gradual biological recalibration. The ancestral human brain did not evolve with retirement plans or decades of post-reproductive life in mind. It evolved to push energy towards survival and reproduction within a relatively compressed time frame. Living far beyond that frame introduces a period where emotional intensity is no longer constantly reinforced by evolutionary pressure. In this light, the softening of extremes may not be decay. It may be a release from a mode designed for a different phase of life. The emotional system is still present, but it is no longer operating under the same urgent conditions that once shaped it on the open plains and within small, interdependent bands of early humans. When we step back and look at the long arc of human time, a quiet pattern appears. For tens of thousands of years, most individuals who survived childhood spent their strongest physical and emotional energy in a relatively narrow window of adulthood. Injury, infection, childbirth complications, and environmental instability limited how many people experienced extended middle age. Those who did reach 40 or beyond were often exceptions rather than the statistical norm. The emotional architecture of our species was formed under this demographic pressure. It was calibrated for urgency during youth, not for decades of sustained intensity afterward. In early human groups, daily life revolved around immediate tasks: locating food, maintaining alliances, responding to threat, securing mates, raising children. Each of these activities carried direct survival consequences. Emotional signals therefore needed to be vivid enough to cut through distraction. A sudden spike of fear triggered flight or defense. A surge of attraction encouraged pair bonding or reproduction. A flash of anger reinforced social boundaries. These reactions were not excessive within that context. They matched the environment. They aligned the nervous system with short-term survival demands. As populations stabilized in later agricultural societies, life expectancy slowly increased. But even then, reaching advanced middle age was uncertain for many. Written historical records from ancient civilizations show that while elders existed, they were fewer relative to the total population than they are today. Only in the last 2 centuries, with improvements in sanitation, medicine, and food supply, has it become common in many regions for large numbers of people to live well beyond 40. This demographic expansion is historically recent. Our emotional systems, however, are ancient. They did not have time to redesign themselves for a lifespan that regularly extends into the 70s or 80s. What often feels like the disappearance of a large portion of emotion after 40 may reflect a mismatch between biological timing and modern longevity. The phase of life that once carried the highest reproductive and competitive pressure is gradually replaced by a period with different social expectations. In ancestral settings, individuals beyond peak reproductive years frequently served as knowledge holders, conflict mediators, and caregivers. These roles required steadiness more than volatility. A calmer baseline would have supported the transmission of memory across generations. When researchers study emotional aging today, they often find that older adults report fewer episodes of extreme negative emotion and show improved capacity for regulation. Neuroimaging studies suggest reduced reactivity in threat processing regions for certain stimuli, alongside maintained or even enhanced activation in areas linked to meaning and perspective. This pattern does not indicate emptiness. It indicates redistribution. The emotional system appears to conserve energy, emphasizing stability over intensity. From the viewpoint of early human survival, this makes sense. Once immediate reproductive urgency decreases, maintaining constant emotional peaks may become metabolically inefficient. The brain is an energy-demanding organ. Modulating emotional amplitude over time could represent an adaptive shift toward long-term resilience rather than short-term mobilization. The phrase 60% of your emotions disappear after 40 captures a subjective impression, not a literal erasure. What disappears may be the sharp edge of reactivity that once served urgent purposes in environments of scarcity and risk. What remains is a quieter layer, shaped by memory, pattern recognition, and accumulated experience. In the vast timeline of our species, extended middle age is a relatively new chapter. The softening of emotional extremes may be the trace of an older script still running inside a longer life than it was originally written for. When people say that a large portion of their emotions disappears after 40, the statement sounds dramatic. Yet before we decide whether something is truly fading, we have to ask a quieter question. What exactly is an emotion in biological terms? In everyday language, emotion feels like a wave inside the mind. In the body, it is a coordinated pattern involving neural circuits, hormones, memory, and perception. It begins with sensory input, moves through evaluation networks in the brain, and ends with physiological changes. Heart rate shifts, muscle tension, altered breathing, hormonal release. In early human environments, these coordinated responses had immediate consequences. A rustle in tall grass triggered amygdala activation, increasing vigilance. A sudden social insult activated circuits related to threat and status, preparing the body for confrontation or withdrawal. These reactions were fast because the brain's emotional system evolved to prioritize survival. The amygdala, often simplified as the brain's fear center, actually functions as a relevance detector. It flags stimuli that might matter for survival or reproduction. During youth, this system tends to respond strongly. Functional imaging studies show heightened amygdala activity in adolescents and young adults when exposed to emotionally charged images or social cues. This increased sensitivity makes sense in an ancestral context. Younger individuals were entering mating competition, forming alliances, and establishing position within small groups. Emotional intensity amplified learning and motivated rapid adaptation. Alongside the amygdala, dopamine pathways shape how rewarding or motivating an experience feels. Dopamine does not simply create pleasure, it signals importance and drives pursuit. In early adulthood, dopamine transmission is often more dynamic. Novelty, risk, and social validation can produce powerful internal responses, These neural patterns align with a life stage where exploration and competition carried high evolutionary stakes. After 40, measurable changes occur in several of these systems. Dopamine receptor density gradually declines across adulthood, influencing how intensely rewards are experienced. The stress response, coordinated by the hypothalamic pituitary adrenal axis, may become less reactive to certain acute stressors, although chronic stress can still have strong effects. Brain regions involved in cognitive control, particularly the prefrontal cortex, continue refining regulatory capacity into midlife. This region helps reinterpret emotional stimuli and dampen impulsive reactions. The result is not emotional absence but altered balance. Signals that once surged quickly may now pass through more layers of evaluation before reaching conscious awareness. From an evolutionary perspective, this transition reflects a shift in functional priority. In a small Paleolithic band, a 20-year-old needed fast, emotionally driven action to secure resources and mates. A 45-year-old with established alliances and accumulated knowledge benefited more from stable judgment than from repeated emotional spikes. The neural system appears to adjust accordingly. Research in lifespan psychology often describes a pattern called the positivity effect, where older adults show a relative preference for positive over negative information in attention and memory. This does not mean they ignore danger. It suggests selective allocation of cognitive resources toward emotionally meaningful and stable experiences. When someone says that 60% of their emotions have disappeared, they may be noticing the reduced frequency of intense highs and lows that once defined earlier decades. The biological components of emotion remain active, but their thresholds and amplification change. The brain does not erase feeling, it recalibrates responsiveness within a longer lifespan than the one for which it was originally optimized. In this light, the disappearance is less about subtraction and more about redistribution within ancient neural circuits now operating in extended middle age. To understand why emotional intensity often shifts after 40, it is necessary to look more closely at how the brain integrates feeling with time. Emotion is not only a reaction to what is happening now, it is also shaped by accumulated memory. In early adulthood, the brain is still forming long-term patterns of prediction. Many experiences are new. Novelty increases dopamine activity and strengthens emotional imprinting in the hippocampus, the region responsible for consolidating memory. When something feels new, it often feels larger. In ancestral human environments, novelty carried risk and opportunity. A new territory could hold food or danger. A new alliance could bring protection or betrayal. Strong emotional responses reinforced learning quickly, allowing individuals to adapt within unstable ecological conditions. By the time someone reaches 40, the landscape of experience has changed. The brain has stored decades of social patterns, environmental cues, and repeated outcomes. Neural pathways become more efficient. The prefrontal cortex, which helps evaluate and regulate emotional signals, tends to operate with greater integration across networks. Instead of reacting primarily through the amygdala's rapid appraisal, information more frequently passes through systems involved in contextual interpretation. This slows the intensity of response. It does not eliminate emotion, it reframes it through memory. In evolutionary terms, this reframing would have been advantageous for individuals who survived beyond peak reproductive years. A person who had lived through droughts, conflicts, and seasonal changes possessed internal models of recurrence. Not every loud sound signaled immediate threat. Not every social slight required confrontation. Experience provided calibration. Over time, the nervous system learns to conserve energy by avoiding unnecessary spikes of arousal. The human brain consumes a large proportion of the body's metabolic resources. Constant emotional activation is costly. In youth, the cost is offset by the benefits of exploration and rapid learning. In midlife, efficiency becomes more adaptive. Neurochemical changes also support this shift. Serotonin systems, which influence mood stability and impulse control, show complex age-related patterns but are often associated with increased emotional regulation in later adulthood. At the same time, structural brain imaging reveals gradual changes in limbic regions alongside relative preservation of areas supporting executive control. The balance between emotional drive and cognitive oversight slowly adjusts. From the perspective of early human survival, this adjustment would have reduced intra-group conflict. Small bands relied on cohesion. Individuals with moderated reactivity could serve as mediators or advisors. Archaeological findings of elderly individuals with healed fractures or dental wear indicate sustained social care. This suggests that older members remained integrated within the group. A stable emotional presence may have contributed to that integration. In the modern world, where lifespan extends well beyond ancestral expectations, this recalibration becomes more visible. People compare their current internal landscape with the intensity of earlier decades. They may interpret the difference as disappearance. Yet what has likely changed is the threshold for activation. Emotional systems that once responded sharply to every social cue now respond selectively. The nervous system shifts from rapid amplification toward measured interpretation. When someone says that a majority of their emotions have faded, they are often describing the reduction of volatility rather than the loss of feeling itself. The core circuitry remains. It has simply adapted to a stage of life where accumulated memory, social stability, and long-term perspective alter how signals are processed. In the context of a species shaped by short, uncertain lives, this quieter pattern may represent the natural extension of a system that was never originally optimized for decades of extended middle age. Another layer of emotional change after 40 emerges when we examine how the brain processes threat and uncertainty across the lifespan. In early adulthood, uncertainty tends to trigger heightened neural activation. Ambiguous social signals, financial risk, or romantic instability can produce strong emotional responses. From an evolutionary standpoint, this heightened sensitivity increased survival chances in unpredictable environments. When early humans moved across open terrain or entered unfamiliar territories, assuming potential danger was often safer than assuming safety. The amygdala and related limbic structures evolved to err on the side of caution. Youthful brains typically display stronger reactivity to uncertain or socially evaluative situations, especially when status or belonging is at stake. Belonging was not symbolic in ancestral bands. It was a condition for survival. Exclusion could mean isolation from shared food, protection, and collective defense. Emotional intensity reinforced vigilance towards social cues. By midlife, however, the social landscape often stabilizes. Many individuals have established long-term partnerships, defined social roles, and predictable routines. Neural studies indicate that older adults frequently show reduced amygdala activation in response to certain negative stimuli compared to younger adults. This pattern has been observed in controlled laboratory settings using emotionally charged images or scenarios. The reduction does not imply indifference. It suggests that the brain may allocate attention differently. Instead of amplifying every potential threat, it may filter more selectively. This filtering can feel like emotional dampening. In ancestral settings, such filtering would have conserved energy once primary reproductive competition decreased. A 45-year-old in a small hunter-gatherer group was less likely to be engaging in the same status battles as a 25-year-old. The survival of the group depended not only on speed and aggression, but also on continuity and memory. Emotional systems that remained constantly reactive could destabilize group cohesion. Moderation supported social harmony. Hormonal transitions also contribute to this recalibration. In men, gradual declines in testosterone across adulthood can influence dominance behaviors and competitive drive. In women, perimenopause and menopause involve significant shifts in estrogen and progesterone, hormones that interact with neurotransmitter systems involved in mood and stress. These biological transitions are complex and vary widely among individuals, yet they consistently mark a shift away from the hormonal peaks of early adulthood. The result may include changes in how strongly certain stimuli evoke emotional arousal. Importantly, research in lifespan development often shows that emotional well-being does not decline steadily with age. Many studies report that middle-aged and older adults experience similar or even higher levels of overall life satisfaction compared to younger adults. The intensity of moment-to-moment emotion may lessen, but stability often increases. This suggests that what feels like disappearance may be transformation. From the vantage point of early human history, this transformation aligns with shifting adaptive needs. The emotional system originally evolved to prioritize survival during physically and socially volatile years. As individuals moved beyond that volatile phase, a moderated pattern may have enhanced long-term contribution to the group. In modern extended lifespans, this shift becomes more visible because the period after 40 now spans decades rather than a brief extension. When someone senses that a large percentage of their emotional extremes have softened, they are observing the natural recalibration of neural systems designed in a different demographic era. The ancient brain remains active, but its thresholds, priorities, and amplification patterns gradually adjust to a stage of life where urgency is no longer the primary evolutionary demand. There is a period in human life when emotion feels amplified in every direction. Between the late teenage years and the mid-30s, many individuals experience sharper joy, deeper disappointment, stronger attraction, and more intense anger. This pattern is not accidental. It reflects a convergence of biology, social structure, and evolutionary timing. In early human history, this window represented the core reproductive and competitive phase of life. Energy, fertility, and physical capacity were at their peak. Emotional intensity supported this phase by increasing motivation and vigilance. In small hunter-gatherer bands, status influenced access to mates, food distribution, and protection. Emotional signals helped individuals navigate these high-stakes dynamics quickly. Attraction drove pair formation. Jealousy guarded bonds. Anger deterred rivals. Fear sharpened awareness during conflict. The body reinforced these processes through hormonal elevation. Testosterone and estrogen levels are generally higher in early adulthood, shaping behavior, confidence, and sensitivity to social evaluation. Dopamine pathways respond strongly to novelty and reward, making achievements and romantic success feel particularly vivid. The brain during this stage tends to prioritize immediate social and environmental cues. Neuroimaging research often shows robust activation in limbic regions when younger adults encounter emotionally charged stimuli. This does not mean younger individuals lack control, but it does mean their emotional systems are tuned toward rapid engagement. In ancestral landscapes, this tuning increased the probability of reproductive success before disease or injury shortened lifespan. The environment itself reinforced intensity. Living in close proximity to a small group meant that conflicts, alliances, and romantic dynamics unfolded face to face. There was little anonymity. Every interaction could influence survival outcomes. Emotional signals needed to be strong enough to shape behavior decisively. A hesitation in defending territory or a delay in responding to courtship cues could carry real costs. As a result, the emotional amplitude of early adulthood likely provided adaptive advantage. When modern individuals compare their current emotional state after 40 with the intensity of earlier decades, they are often comparing two different biological phases. The earlier phase was optimized for competition and expansion. The later phase emerges after many foundational structures have already been established. Partnerships may be stable, social roles may be defined, economic survival may depend less on physical dominance and more on accumulated skill. In this new context, the same level of emotional volatility would not necessarily increase success. In fact, excessive reactivity could threaten stability. Research in lifespan development consistently shows that impulsivity tends to decline with age, while emotional regulation improves. This shift reflects changes in both neurochemistry and social expectation. In early human groups, individuals beyond peak reproductive years often shifted from direct competition toward advisory or supportive roles. The group benefited from their memory and experience rather than from their speed of reaction. A calmer emotional baseline would have complemented this transition. The sensation that a portion of one's emotional intensity has faded after 40 may therefore represent the natural closing of a phase that once carried the highest biological urgency. It is not that emotion itself disappears. It is that the stage of life that required heightened emotional peaks gradually gives way to a stage shaped by continuity and stability, echoing patterns present since the earliest human societies. In early adulthood, emotional intensity is not only a product of hormones and neural sensitivity, it is reinforced by demographic structure. In ancestral human groups, the majority of the population was young, High birth rates combined with significant mortality created a pyramid-shaped age distribution. This meant that social life was dominated by individuals in their reproductive and competitive years. When most members of a group are navigating courtship, alliance formation, and status negotiation, the emotional climate of the entire community reflects that pressure. Signals of attraction, rivalry, loyalty, and betrayal circulate constantly. Emotional energy becomes part of the social atmosphere. Within this structure, strong feeling serves as communication. A visible display of anger can deter aggression. A public expression of affection can solidify bonds. Fear transmitted quickly can mobilize collective defense. Emotional signals were not private experiences contained inside individual minds. They were adaptive tools embedded in group dynamics. In small hunter-gatherer bands, cooperation and conflict were immediate and personal. Every emotional reaction influenced the stability of the group. The young adult years, therefore, were not only biologically intense but socially amplified. By contrast, individuals who reached their 40s in ancestral settings often existed within a different demographic position. They were fewer in number relative to the youth cohort. Their reproductive urgency had typically declined. Their social leverage often derived from experience rather than from physical dominance. Anthropological studies of contemporary hunter-gatherer societies suggest that older adults frequently act as knowledge holders, storytellers, mediators, or caretakers. These roles rely less on emotional extremes and more on continuity and measured judgment. In such roles, excessive volatility could undermine authority. Stability becomes a social asset. The body mirrors this transition. As testosterone and estrogen levels gradually shift, the behavioral tendencies associated with peak reproductive competition tend to soften. Dopamine-driven novelty-seeking may decline, reducing the intensity of pursuit-related emotions. This does not eliminate desire or motivation, but it adjusts their amplitude. At the same time, cognitive control networks strengthen through decades of use. The prefrontal cortex becomes more efficient at modulating impulsive responses. From the standpoint of early human survival, this pattern aligns with shifting adaptive priorities. A 25-year-old needed to secure mates and resources rapidly. A 45-year-old needed to ensure group continuity, support offspring, and maintain alliances. The emotional requirements of these tasks differ. When modern individuals notice that their reactions feel less dramatic than they once did, they are often comparing two distinct social positions embedded in deep evolutionary history. The emotional landscape of youth was shaped by high competition within a youth-dominated demographic structure. The emotional landscape of midlife reflects integration within a more stable network. The sensation that a large portion of emotion has diminished may be linked to this demographic transition. The brain recalibrates not only because of internal chemistry, but because the surrounding social structure historically demanded different patterns of response at different ages. In a species where extended middle age was once relatively rare, the gradual softening of emotional extremes may have signaled entry into a role that prioritized balance over intensity, echoing demographic patterns that shaped human groups for tens of thousands of years. There is another dimension to the peak of emotional intensity in early adulthood that becomes clearer when we consider risk. In ancestral human environments, survival depended not only on cooperation but on calculated exposure to danger. Hunting large animals, migrating across unfamiliar terrain, negotiating with neighboring groups, and competing for mates, all required individuals willing to accept uncertainty. Younger adults were biologically positioned to take these risks. Elevated dopamine activity increases reward anticipation and reduces sensitivity to potential loss. Testosterone influences competitive behavior and willingness to confront rivals. Neural circuits linking the amygdala and striatum respond strongly to both threat and opportunity. The emotional system during these years amplifies the potential gains of action while tolerating the costs of failure. In small Paleolithic bands, this pattern served the group. Without individuals prepared to explore new territories or challenge threats, resources would stagnate and vulnerability would increase. Emotional intensity supported exploration and confrontation. Fear sharpened reaction time, yet it was balanced by the motivational pull of potential reward. Anger mobilized defense. Attraction ensured reproduction. These responses were not excessive within that context. they were proportionate to environmental volatility. After 40, the balance of risk often changes. In ancestral societies, individuals who survived to this age had already demonstrated resilience. They carried memories of past dangers and outcomes. Experience recalibrates risk perception. Neurobiological studies show that with age, sensitivity to reward and novelty often declines, while reliance on prior knowledge increases. The brain shifts from rapid reward-seeking toward pattern recognition. This transition reduces the frequency of emotionally charged risk-taking. The stakes also transform. By midlife, individuals are more likely to have dependent offspring and established alliances. Risk no longer serves only personal advancement. It carries consequences for the stability of the group. Emotional moderation becomes adaptive. A reduced amplitude of thrill or rage lowers the likelihood of destabilizing decisions. Hormonal transitions reinforce this recalibration. Gradual decreases in testosterone and shifts in other endocrine systems correspond with reduced aggressive impulses in many individuals. The prefrontal cortex, having matured and strengthened across decades, exerts more consistent regulatory influence over limbic responses. The combined effect is not emotional emptiness, but emotional containment. When modern adults describe feeling that a large portion of their emotional extremes has softened, they may be perceiving this containment. In evolutionary terms, the early adult phase prioritized expansion and reproduction under uncertain conditions. The later phase prioritized continuity and protection of accumulated investment. The emotional system adapts accordingly. This pattern aligns with archaeological evidence suggesting that older adults contributed through knowledge transmission and conflict mediation, rather than through direct competition. A moderated emotional baseline would have supported these roles. In the modern world, where lifespan routinely extends far beyond ancestral expectations, the contrast between early intensity and later moderation becomes more pronounced because the later phase lasts decades. What once may have been a relatively brief extension beyond peak competition is now a substantial portion of life. The sensation that 60% of emotional intensity has disappeared may reflect the closing of a risk-amplified chapter that dominated early adulthood. What remains is a system recalibrated for stability in a life that now extends far beyond the temporal boundaries within which it first evolved. For most of human history, reaching the age of 40 placed someone near the outer edge of the population curve, not because the human body was incapable of living longer, but because external pressures reduced the number of people who did. High infant mortality lowered average life expectancy at birth. Infectious disease, injuries, childbirth complications, and resource scarcity further narrowed the group that survived into later adulthood. Anthropological studies of skeletal remains from prehistoric populations show evidence of individuals living into their 40s and beyond, yet they were proportionally fewer than in modern societies. The demographic structure was different. A community might contain elders, but it was not built around decades of post-reproductive life as a common expectation. This demographic reality matters when considering emotional design. Natural selection operates most strongly during the years that influence reproduction. Traits that increase survival and mating success in early adulthood are more likely to be passed forward. Traits that influence well-being decades after reproduction exert weaker evolutionary pressure. If emotional intensity in youth increased the probability of securing mates, defending resources, and raising offspring to maturity, it would be strongly reinforced. Whether that same intensity remained optimal at 60 would have mattered less in environments where few individuals reach that age. In this sense, the emotional system may be front-loaded. It delivers peak amplitude during the years when evolutionary stakes are highest. After that period, its regulation may shift without strong selective correction. This does not mean that aging brains deteriorate by default. It means the blueprint prioritized early life performance. In ancestral contexts, once offspring survived to independence, the direct reproductive urgency declined. Individuals who reached midlife often transitioned into roles centered on knowledge retention, coordination, and cultural continuity. Archaeological findings such as healed fractures, degenerative joint changes, and long-term dental wear suggest that some older adults were supported by their groups, indicating ongoing social value. Yet the number of years spent in this stage was likely shorter on average than today. The extended middle age common in industrialized societies is historically recent, largely emerging over the past 2 centuries, with improvements in medicine, sanitation, and food stability. Our neural architecture, however, reflects much older conditions. When people today sense that a large portion of their emotional extremes fades after 40, they may be encountering a demographic mismatch. The brain evolved under assumptions of shorter lifespans and compressed reproductive timelines. Now it operates within decades of additional life. Emotional recalibration that once marked the approach of later adulthood may now occur in the middle of a much longer arc. Studies in evolutionary biology suggest that many physiological systems show peak function aligned with reproductive years, followed by gradual shifts in resource allocation. The brain, as an energy-intensive organ, is no exception. Modulating emotional amplitude over time may conserve metabolic resources while supporting long-term social stability. In a species that did not historically expect 40 more years after 40, the sensation of emotional softening may reflect the extension of a stage that was once brief. The disappearance is not abrupt removal. It is a gradual tapering shaped by a demographic history in which extended middle age was possible but not widespread, and therefore not the primary target of evolutionary optimization. When life expectancy begins to extend beyond its ancestral range, subtle mismatches appear between biological timing and social reality. For most of human existence, surviving into the 40s often meant that an individual had already completed the most reproductively intense phase of life. Offspring, if they survived, were approaching independence. Physical strength had passed its peak. In small foraging groups, daily tasks still required effort, but the nature of contribution gradually shifted from speed and competition toward guidance and memory. Emotional systems that had once surged with urgency now operated in a different context. The demographic structure no longer placed the individual at the center of mating rivalry, it placed them at the center of continuity. Modern societies have altered this structure dramatically. With advances in medicine, sanitation, and agriculture, a large portion of the population now routinely lives into their 70s and beyond. Middle age spans decades rather than a brief transitional period. The emotional recalibration that may have once accompanied the approach of later adulthood now unfolds in the middle of an extended lifespan. From the standpoint of evolutionary history, this is new. Our neural circuitry did not evolve under conditions where 40 marked the beginning of a second, equally long chapter. It evolved under conditions where 40 often approached the later boundary of expected survival. This demographic extension helps explain why emotional intensity may feel reduced relative to youth. The emotional system, optimized for early life competition and reproduction, gradually shifts once those priorities decline. Hormonal changes after 40 are part of this transition. In men, testosterone levels typically decrease gradually, influencing dominance behavior and competitive drive. In women, perimenopause and menopause involve pronounced shifts in estrogen and progesterone, hormones that interact with neurotransmitter systems governing mood and stress. These changes are measurable and consistent across populations, though their subjective effects vary widely. From a biological perspective, they signal a movement away from peak reproductive investment. When reproductive investment decreases, the evolutionary incentive for high-amplitude emotional reactivity diminishes as well. In ancestral environments, maintaining constant emotional intensity beyond peak fertility may have offered limited advantage. Instead, stability and resource management would have supported group survival. Archaeological and ethnographic evidence suggests that older individuals often contributed through knowledge transmission, childcare support, and mediation. Emotional moderation enhances these roles. A calmer nervous system facilitates conflict resolution and long-term planning. In modern life, however, individuals continue to engage in complex careers, financial planning, and social competition well past 40. The environment still demands attention and adaptation, yet the internal biological script may already be shifting toward conservation. This can create the impression that a portion of one's emotional drive has faded while external expectations remain high. The sense that 60% of emotional intensity has disappeared may reflect this tension between ancient demographic design and contemporary longevity. What once marked the gradual entry into later adulthood now occurs during a prolonged middle stage. The emotional system is not malfunctioning. It is following a trajectory shaped by hundreds of thousands of years when extended middle age was shorter and less central to survival strategy. In that context, the softening of extremes appears less mysterious. It becomes a trace of demographic history written into neural timing, now unfolding across a lifespan far longer than the one in which it first evolved. There is a concept in evolutionary biology known as selection shadow. It refers to the idea that natural selection becomes weaker for traits that express later in life, especially after the main reproductive years. If most individuals in ancestral populations did not consistently survive far beyond 40, then the fine-tuning of systems active in extended middle age would have faced limited evolutionary pressure. This does not mean that later life was irrelevant. It means that the strongest shaping forces acted earlier. Emotional intensity in youth directly influenced mating success, alliance formation, and the survival of offspring. Emotional calibration at 60 influenced reproduction far less. Within this framework, it becomes easier to understand why the emotional system might deliver peak amplitude in early adulthood and then gradually soften. The brain was optimized for a life stage that determined genetic continuation. Once that stage passed, the need for intense volatility diminished. The nervous system could afford to reduce reactivity without jeopardizing evolutionary fitness. In ancestral settings, individuals who survived into later adulthood still contributed meaningfully, but the urgency of their emotional responses was less critical to reproductive outcome. Archaeological evidence shows that some older individuals lived with chronic conditions, healed fractures, or degenerative changes, suggesting prolonged survival despite physical decline. Their presence indicates social support structures within early human groups. These individuals likely played stabilizing roles. Emotional steadiness would have reinforced their authority as knowledge holders and mediators. High-amplitude reactivity might have disrupted group cohesion. From a demographic perspective, the proportion of people living decades beyond peak fertility was small compared to today. In modern societies, the majority of adults will spend 30 or 40 years after 40. This extended period now represents a central chapter of life rather than a marginal one. Yet our neural architecture remains rooted in a history where this stage was shorter and less universally experienced. When someone senses that a large share of their emotional intensity has faded, they may be encountering the boundary of evolutionary optimization. The systems that once surged with urgency are no longer under the same selective demand. Hormonal transitions reinforce this boundary. Declines in reproductive hormones signal shifts in bodily investment. Neurochemical systems adjust accordingly. Dopamine responses to novelty may decrease. Stress reactivity may moderate. These patterns are consistent with an organism reallocating resources from rapid expansion toward maintenance. Importantly, reduced emotional amplitude does not equate to reduced meaning. Research in lifespan psychology frequently shows that older adults maintain or increase overall life satisfaction despite experiencing fewer extreme emotional swings. Stability becomes a source of well-being. In evolutionary terms, this may represent a shift from intensity to endurance. The early adult phase prioritized rapid action in unpredictable environments. The later phase prioritized continuity within established networks. The concept of 60% disappearing is a metaphor for this transition. What diminishes is not the capacity to feel, but the evolutionary urgency that once amplified feeling to secure survival and reproduction. In a world where extended middle age is now common, the softening of extremes may feel unfamiliar, even unsettling. Yet it may simply reflect the ancient limits of a system that was never required to remain at peak emotional amplitude across the long decades we now routinely inhabit. When people speak about emotional change after 40, they often describe it as psychological. Yet beneath subjective experience lies a measurable biological transition. Hormones are chemical messengers that influence how neural circuits respond to the world. During early adulthood, reproductive hormones are typically near their lifetime peak. Testosterone in men supports competitive behavior, risk tolerance, and sensitivity to status. Estrogen and progesterone in women interact with neurotransmitter systems that influence mood regulation, reward processing, and stress reactivity. These hormones do not create emotion by themselves, but they amplify the intensity with which emotional signals are experienced. In ancestral human environments, Elevated reproductive hormones during youth aligned with the evolutionary imperative to secure mates and raise offspring. Emotional urgency reinforced reproductive investment. After 40, endocrine patterns gradually shift. In men, testosterone levels tend to decline slowly with age. This decline is not abrupt in most cases, but it is measurable across populations. Lower testosterone is associated in many studies with reduced aggression and competitive drive, though the relationship is complex and influenced by social context. In women, the transition toward menopause typically occurs between the mid-40s and early 50s. Estrogen and progesterone levels fluctuate and eventually decrease. These hormonal shifts interact with brain systems, regulating mood and stress. Some individuals experience temporary volatility during this transition, but over time, many report a stabilization of emotional extremes. From a neurobiological perspective, hormones modulate the sensitivity of neurotransmitter systems such as dopamine and serotonin. Dopamine influences motivation and reward salience. Higher dopamine responsiveness during youth contributes to stronger reactions to novelty, achievement, and social validation. With age, dopamine receptor availability often declines. This does not eliminate pleasure or motivation, but it may reduce the amplitude of emotional highs. Serotonin, associated with mood stability and impulse control, also changes across the lifespan in ways that can support increased regulation. These endocrine and neurochemical shifts reflect resource reallocation within the body. In early human history, reproductive capacity had a narrow window. Maximizing emotional intensity during that window increased the probability of successful mating and child-rearing. Once reproductive potential declined, the biological advantage of sustained high-amplitude emotional reactivity decreased. The body gradually adjusts its internal chemistry accordingly. Archaeological evidence suggests that older individuals often contributed through accumulated knowledge rather than through physical dominance. A hormonal profile favoring stability over volatility would have supported this role. Emotional moderation enhances planning, teaching, and mediation within small groups. In modern societies, where extended lifespans are common, these hormonal changes occur while individuals continue to navigate careers, complex relationships, and social competition. The external demands may not decline as sharply as they once did in ancestral settings, yet the internal biological trajectory continues. This mismatch can create the impression that a significant portion of emotional intensity has disappeared. The change is not random. It follows endocrine patterns shaped by evolutionary history. The emotional system was calibrated to peak when reproductive stakes were highest. After 40, as hormonal signals shift away from peak fertility, the amplification of certain emotions naturally softens. What feels like loss may be the body moving from a phase of expansion toward a phase of conservation, reflecting patterns that trace back to the earliest chapters of human demographic history. Hormonal change after 40 is not limited to reproductive systems. It is part of a broader recalibration of the body's internal chemistry, including stress hormones and metabolic regulators that shape emotional tone. In early adulthood, the stress response is typically fast and reactive. When confronted with uncertainty or threat, the hypothalamic pituitary adrenal axis releases cortisol and adrenaline, mobilizing energy and sharpening focus. In ancestral environments, this rapid mobilization increased the likelihood of escaping danger or defending resources. Emotional intensity was inseparable from physiological activation. Fear accelerated the heart. Anger tightened muscles. The body prepared for immediate action. Over time, however, patterns of stress, responsiveness shift. Research suggests that while chronic stress can remain harmful at any age, acute stress reactivity to certain stimuli often decreases in midlife compared to youth. This moderation does not eliminate the stress response. It adjusts its threshold. Decades of exposure to recurring challenges may recalibrate how quickly the system activates. Experience informs expectation. The brain becomes more efficient at distinguishing between immediate threat and manageable difficulty. From an evolutionary perspective, this recalibration would have conserved energy in individuals who had already survived numerous cycles of scarcity and danger. Cortisol interacts closely with emotional processing centers such as the amygdala and hippocampus. Repeated high activation can amplify emotional volatility. Gradual moderation of this system reduces the amplitude of those spikes, In early human groups, a constantly high stress response beyond peak reproductive years may have offered limited benefit. Stability in older adults would have supported social cohesion. Anthropological observations of small-scale societies often describe elders as stabilizing presences within conflict. Their emotional reactions tend to carry weight precisely because they are not impulsive. Another dimension involves metabolic regulation. The brain consumes significant energy, and emotional arousal is metabolically demanding. As the body ages, energy allocation strategies shift toward maintenance and repair. This includes changes in insulin sensitivity, inflammatory responses, and overall metabolic efficiency. Emerging research links chronic inflammation to mood disorders and emotional dysregulation. Many individuals experience subtle shifts in inflammatory markers with age, influenced by lifestyle and genetics. When metabolic systems recalibrate, emotional expression may change in parallel. The body seeks equilibrium rather than constant activation. In the ancestral context, once reproductive urgency declined and social roles stabilized, conserving energy would have increased long-term survival within the group. Emotional moderation may therefore reflect an integrated physiological transition rather than a purely psychological one. In modern extended lifespans, this integrated transition unfolds while individuals remain engaged in demanding social and professional environments. The contrast between internal recalibration and external expectation can heighten awareness of change. When someone feels that a large percentage of their emotional intensity has softened, they may be sensing this broader hormonal and metabolic shift. The nervous system does not simply age, it reorganizes. Stress responses become more selective. Energy allocation favors endurance over rapid mobilization. What appears as disappearance may be the outcome of coordinated endocrine and metabolic adjustments shaped by evolutionary history, now expressed within a lifespan far longer than the one in which those adjustments first evolved. There is also a slower hormonal rhythm that shapes emotional change after 40, one that unfolds quietly over years rather than days. It involves the gradual interaction between reproductive hormones, stress hormones, and the brain's long-term plasticity. During early adulthood, endocrine systems tend to operate in coordinated peaks. Reproductive hormones amplify motivation and attachment. Dopamine enhances reward anticipation. Cortisol responds sharply to perceived threat. Together, these systems create a landscape of vivid emotional contrast. High peaks and deep valleys are biologically supported. In ancestral settings, this coordinated intensity aligned with a narrow window in which survival and reproduction were most urgent. By midlife, however, the coordination shifts. Testosterone declines slowly in men, often beginning in the 30s and continuing gradually. In women, the transition toward menopause involves fluctuating estrogen levels before eventual reduction. Estrogen interacts closely with serotonin and dopamine pathways, influencing mood sensitivity and reward perception. When estrogen declines, the modulation of these neurotransmitters changes as well. This can temporarily increase emotional variability during transition years. Yet over time, many individuals experience a stabilization of emotional amplitude. The endocrine system moves away from reproductive emphasis toward maintenance. This shift affects neural plasticity. The brain remains capable of change throughout life, but the speed and intensity of synaptic remodeling often decrease with age. In youth, heightened plasticity allows rapid adaptation to new social environments and mating opportunities. Emotional experiences during this period can imprint strongly. After 40, accumulated neural patterns become more established. Responses draw more heavily on existing pathways rather than forming entirely new ones. The result is often predictability rather than volatility. From an evolutionary perspective, this predictability would have supported continuity within small groups. Individuals who survived into later adulthood carried extensive experiential maps of social and environmental patterns. A nervous system less prone to abrupt swings may have enhanced their reliability as advisors and caregivers. Hormonal moderation thus intersects with neural consolidation. Emotional expression becomes less about rapid exploration and more about sustained integration. Modern research in developmental psychology often finds that while emotional intensity may decline, emotional complexity can increase. Older adults frequently report greater ability to hold mixed feelings simultaneously, such as gratitude and regret. without being overwhelmed by either. This reflects a brain that integrates rather than amplifies. In ancestral human societies, such integration would have reinforced intergenerational transmission of knowledge. A calm recounting of past hardship could guide younger members without triggering destabilizing fear. When contemporary individuals describe that 60% of their emotions have disappeared, they are often referring to the fading of sharp spikes rather than the disappearance of depth. The endocrine recalibration after 40 reduces amplification but does not erase capacity. The emotional system transitions from a mode optimized for expansion and reproduction to one oriented toward maintenance and continuity. In a species whose evolutionary timeline assumed shorter lifespans, this transition may have once marked the approach of later adulthood. Today, it unfolds across decades of extended middle age. What feels like loss may be the biological signature of a system shifting priorities, conserving energy, and stabilizing perception within a life that now extends far beyond the window for which its original hormonal choreography was designed. Beyond hormones and neurotransmitters, another transformation unfolds after 40 within the structure of the brain itself. The prefrontal cortex, located behind the forehead, plays a central role in planning, impulse control, and emotional regulation. During adolescence and early adulthood, this region is still refining its connections. Emotional signals from limbic structures such as the amygdala often reach conscious awareness quickly, sometimes before reflective evaluation is fully engaged. This pattern contributes to the vividness and speed of emotional reactions in youth. In ancestral human settings, rapid mobilization could determine survival outcomes. A swift defensive response to threat or a bold pursuit of opportunity increased the likelihood of securing resources and mates. As the brain matures through the 30s and into midlife, connectivity between the prefrontal cortex and limbic regions strengthens. Longitudinal neuroimaging studies suggest that regulatory networks become more efficient over time. The prefrontal cortex exerts more consistent top-down modulation on emotional impulses. This does not eliminate emotional experience. It adjusts its trajectory. Signals that once surged unchecked now pass through layers of interpretation shaped by memory and context. The result is often described subjectively as calmness or reduced intensity. From an evolutionary perspective, this neural rebalancing aligns with changing social roles. In small hunter-gatherer groups, individuals beyond peak reproductive years frequently occupied positions that required measured judgment. Mediating disputes, allocating resources, or transmitting knowledge demanded emotional steadiness. An overactive limbic response in such roles could destabilize group cohesion. Strengthened prefrontal regulation would have supported reliability and foresight. Structural brain changes across midlife are gradual. Certain regions show modest reductions in volume, while others maintain function through adaptive reorganization. Importantly, age-related change does not imply uniform decline. Cognitive domains related to vocabulary, accumulated knowledge, and pattern recognition often remain stable or improve into middle age. Emotional processing follows a similar pattern. Studies frequently find that older adults demonstrate greater capacity to reinterpret negative events in less distressing ways. This cognitive reframing is associated with increased activation in regulatory regions during emotional tasks. In ancestral contexts, the ability to reinterpret rather than react impulsively would have conserved energy and reduced conflict. Life in small bands required cooperation across generations. Emotional containment became adaptive. In modern extended lifespans, this neural shift unfolds while individuals continue to face complex demands. Careers, financial responsibilities, and social networks remain active beyond 40. The contrast between earlier volatility and later regulation may therefore feel pronounced. When someone says that a majority of their emotional extremes have faded, they may be sensing the strengthened influence of regulatory circuits. The limbic system still responds to threat, loss, and joy, yet its signals are filtered through decades of integration. The emotional system does not vanish, it becomes layered. What once manifested as sharp peaks may now appear as controlled gradients. In a species whose neural architecture evolved under shorter lifespans, this rebalancing may have marked the approach of elderhood. Today it occurs during an extended middle period. The perception of disappearance may be the subjective reflection of a brain shifting from rapid, limbic-driven urgency towards sustained, prefrontal-guided stability, echoing patterns shaped by early human social structure. As the brain moves through midlife, the balance between emotional generation and emotional regulation continues to shift in subtle but measurable ways. The limbic system, including structures such as the amygdala and hippocampus, remains active across the lifespan. It does not shut down. What changes is the pattern of communication between these regions and the networks responsible for reflection and long-term planning. Functional connectivity studies show that with age, there is often increased coordination between prefrontal areas and limbic centers during emotional tasks. This coordination allows emotional signals to be interpreted within a broader narrative rather than experienced as isolated surges. In early adulthood, an insult or rejection may trigger a rapid cascade of physiological arousal. The heart rate increases, muscles tense, and attention narrows. The reaction feels immediate and consuming. In ancestral human environments, this immediacy was protective. Social standing influenced access to mates and cooperative alliances. A quick, intense response to status threat could deter rivals. By midlife, however, many individuals have established more stable social networks. Neural circuits reflect this accumulated stability. The prefrontal cortex, having matured through decades of experience, can contextualize social cues. An insult may still be registered as unpleasant, but it is more likely to be evaluated against past patterns. The emotional system becomes less reactive to single events and more responsive to long-term meaning. This shift is supported by structural changes. While certain grey matter volumes decline modestly with age, white matter connectivity and specific regulatory pathways can remain robust into midlife. Efficient communication between brain regions supports measured response rather than impulsive escalation. Emotional signals still arise, yet they are integrated into a larger framework of memory and expectation. From an evolutionary perspective, this integration would have supported roles centered on guidance rather than competition. In small hunter-gatherer bands, older individuals who could interpret conflict without immediate escalation contributed to group cohesion. Emotional restraint became adaptive in a context where maintaining alliance stability was crucial for survival. Another dimension involves attentional focus. Research often finds that older adults show selective attention toward emotionally meaningful information, while filtering out certain negative stimuli. This pattern, sometimes described as a positivity bias, reflects changes in motivational priorities. In early adulthood, attention is drawn strongly to threat and opportunity. In midlife, attention may shift toward maintaining well-being and relational stability. This does not imply denial of reality. It reflects adaptive prioritization. The brain allocates cognitive resources differently when reproductive urgency declines. The sensation that a large portion of emotional intensity has faded may therefore be tied to attentional recalibration. Fewer stimuli are flagged as urgent. Emotional peaks become less frequent because fewer events are interpreted as requiring immediate mobilization. This recalibration conserves energy. The human brain is metabolically expensive, consuming a significant proportion of the body's resources. Constant high arousal states would be inefficient over decades of extended middle age. By reducing unnecessary spikes, the system favors endurance. In modern society, where lifespan routinely extends beyond ancestral norms, this regulatory shift occupies a large portion of life. The contrast between youthful volatility and midlife moderation becomes more visible because the latter now spans decades, rather than a brief period before decline. When someone senses that 60% of their emotions have disappeared after 40, they may be perceiving the cumulative effect of strengthened regulatory networks, altered attentional priorities, and integrated memory processing. The limbic system remains intact. Joy, grief, attachment, and fear are still present, yet they are filtered through neural pathways optimized for stability rather than rapid expansion. In the long history of our species, such stability may have once marked the transition into elder roles within small communities. Today, it unfolds within a prolonged middle stage, shaped by neural patterns that evolved under very different demographic expectations. As midlife progresses, the brain does not simply regulate emotion more efficiently. It also begins to value predictability over intensity. This shift is subtle, but it influences how emotional events are encoded and remembered. In early adulthood, emotionally charged experiences often become vivid, defining memories. High levels of arousal strengthen consolidation in the hippocampus, especially when combined with novelty. In ancestral environments, remembering the details of a dangerous encounter or a successful alliance could shape future survival decisions. Strong emotion etched events into memory with clarity. After 40, memory systems rely increasingly on pattern recognition rather than on singular dramatic episodes. The hippocampus continues to function, yet decades of accumulated experience provide a broad template for interpreting events. Instead of reacting as if each situation is entirely new, the brain compares current stimuli to stored patterns. This comparison reduces surprise. When surprise diminishes, emotional amplitude often follows. The nervous system shifts from rapid encoding of novel threats to measured integration of familiar scenarios. Neurobiological research suggests that aging brains may show reduced responsiveness to certain high-arousal negative stimuli, while maintaining or even enhancing responses to emotionally meaningful positive information. This does not mean that negative experiences are ignored. It indicates that motivational priorities evolve. In early human societies, youth required rapid acquisition of new information to navigate uncertain environments. In later adulthood, the emphasis moved toward maintaining cohesion and transmitting knowledge. Emotional moderation supported this function. A stable narrative of events, rather than intense reactivity, would have helped younger members interpret group history and avoid past mistakes. There is also evidence that the brain's default mode network, involved in self-referential thought and autobiographical reflection, becomes more integrated with regulatory systems over time. Reflection deepens. Emotional events are woven into broader life narratives rather than experienced as isolated shocks. This integration can feel like softening. The peaks are lower, but the connections are wider. From the standpoint of evolutionary timing, this pattern aligns with a life stage less focused on expansion and more focused on continuity. In small ancestral bands, individuals who survived beyond peak reproductive years were living repositories of memory. Their emotional responses needed to be measured enough to preserve clarity in recounting experience. Excessive volatility could distort transmission of information crucial for survival. The modern perception that 60% of emotional intensity has faded may therefore reflect a transition from episodic intensity to narrative integration. The limbic system remains capable of activation, yet its signals are contextualized within decades of accumulated meaning. The nervous system favors coherence over shock. In a world where extended middle age is now common, this transition unfolds across a long span of years. It may feel like disappearance, because the contrast with youth is pronounced. Yet, from the perspective of human evolutionary history, it may represent a predictable reorientation. The brain shifts from encoding life as a series of urgent episodes to organizing it as an integrated continuum. Emotional experience does not vanish. It changes texture. What once appeared as sharp flashes becomes a steady current, shaped by memory, regulation, and the long arc of a lifespan that now extends far beyond the boundaries in which the emotional system first evolved. By the time an individual reaches 40 in modern society, the internal landscape is not the only thing that has shifted. The social role itself has often changed. In early adulthood, life is typically organized around expansion, building partnerships, establishing identity, competing for position, proving competence, and securing resources dominate attention. These activities are emotionally charged because they influence long-term survival and status. In ancestral human groups, this phase carried direct reproductive consequences. Access to mates, protection, and food depended on visible strength, alliance building, and responsiveness to threat. Emotional intensity supported visibility and action. After 40, however, the center of gravity within social structure often moves. Even in contemporary societies where careers remain active, many individuals transition from proving themselves to stabilizing what they have built. Parenting may shift from direct care to guidance. Professional roles may emphasize mentorship rather than entry-level competition. Social networks tend to become more selective. Anthropological observations of small-scale societies suggest that older adults frequently serve as mediators, advisors, and custodians of collective memory. Their value lies less in physical dominance and more in interpretive authority. In such roles, emotional steadiness becomes an asset. Excessive volatility can undermine credibility. A calm presence, shaped by experience, reinforces group trust. This pattern likely has deep evolutionary roots. In hunter-gatherer bands, survival depended not only on youthful risk-taking but on intergenerational coordination. Individuals who had lived through environmental fluctuations could anticipate patterns others had not yet encountered. Their emotional signals needed to reflect perspective rather than immediacy. When a younger member reacted strongly to a temporary scarcity, an older member's moderated response could prevent panic. Over time, this difference in amplitude may have become associated with age itself. From a biological standpoint, this social transition aligns with hormonal and neural recalibration. As reproductive hormones decline and regulatory networks strengthen, the body supports roles that require patience and measured judgment. The environment no longer demands constant demonstration of strength. Instead, it often rewards reliability. In modern life, this shift is sometimes interpreted as loss. The intensity that once accompanied ambition, romance, or rivalry softens. Yet the responsibilities of midlife frequently require endurance rather than display. Financial planning, long-term caregiving, and professional oversight depend on sustained attention. Emotional moderation conserves energy for these tasks. Sociological research often finds that social networks become smaller but more meaningful with age. Individuals invest in fewer relationships with greater depth. This selective investment reduces exposure to emotionally volatile interactions. Fewer social confrontations mean fewer spikes of anger or jealousy. In ancestral settings, narrowing focus toward close kin and trusted allies would have strengthened group resilience. When someone senses that a significant portion of emotional turbulence has diminished after 40, they may be experiencing the natural consequence of this role transition. The social environment no longer reinforces constant emotional escalation. Instead, it stabilizes around continuity and responsibility. The brain and body, shaped by hundreds of thousands of years of life in small interdependent groups, respond accordingly. Emotional intensity that once signaled urgency now yields to steadiness that signals guidance. In a lifespan that now stretches far beyond ancestral norms, this transition occupies a substantial chapter, making the contrast with youth more visible than it might have been in earlier eras. As individuals move deeper into midlife, social priorities often narrow in deliberate ways. In early adulthood, the social field is wide. Friendships form rapidly, romantic exploration may involve uncertainty, and professional identity is still under construction. Each of these domains carries emotional volatility because outcomes remain unstable. In ancestral human groups, instability was not abstract. It influenced access to shared resources and protection. Emotional signals functioned as rapid feedback within this fluid network. Strong reactions helped recalibrate alliances quickly. By 40, however, many social structures have consolidated. Long-term partnerships may already be established. Professional hierarchies are clearer. The number of daily interactions that directly threaten survival or status tends to decrease. Contemporary research in social psychology often finds that as people age, they become more selective in their relationships. They invest in close, emotionally meaningful ties rather than in broad networks. This selectivity reduces exposure to unpredictable social evaluation. Fewer new alliances mean fewer volatile negotiations. From an evolutionary standpoint, this narrowing would have supported group cohesion. In small bands, older individuals who concentrated on close kin and trusted allies strengthened stability. Emotional moderation within these relationships preserved trust. There is also a shift in motivational orientation. Younger adults frequently orient toward future expansion. Goals revolve around gaining, achieving, and proving. These forward-looking ambitions amplify emotional intensity because outcomes remain uncertain. After 40, Goals often shift toward maintenance and preservation. Protecting family, sustaining health, and safeguarding accumulated resources becomes central. Maintenance requires consistency rather than dramatic fluctuation. Emotional peaks that once energized exploration may become less adaptive when stability is the objective. The body's internal systems align with this motivational shift. Hormonal recalibration reduces the biological reinforcement of constant competition. Neural networks supporting long-term planning gain relative influence. Together, these changes create a social-emotional environment in which dramatic highs and lows are less frequent. In ancestral settings, such moderation would have lowered the risk of intra-group conflict. An older member reacting impulsively to minor disputes could destabilize cooperation essential for survival. Emotional steadiness thus became socially advantageous. In modern societies, extended middle age expands this stable phase across decades. The contrast with youth becomes sharper because both stages are prolonged. When individuals notice that a large share of their emotional turbulence has faded, they may be observing the combined effect of social selectivity and motivational reorientation. The reduction in daily unpredictability reduces the number of triggers for extreme reaction. Emotional experience does not disappear. It shifts toward depth within fewer domains. Relationships may feel calmer yet more meaningful. Professional roles may evoke less excitement yet greater confidence. From the perspective of human evolutionary history, this pattern mirrors the transition from competitive expansion to protective continuity within small communities. Emotional amplitude adjusts to fit the social architecture of the life stage. What once required rapid escalation now benefits from sustained equilibrium. The perception that 60% of emotion has vanished may reflect this narrowing and deepening of social investment, a pattern rooted in demographic and ecological conditions that shaped our species long before modern longevity made midlife a dominant chapter of human experience. There is also a quieter shift that unfolds after 40, one that involves identity rather than hormones or neural wiring alone. In early adulthood, identity is often in motion. Individuals experiment with roles, relationships, and ambitions. Success and failure feel amplified because they influence who one is becoming. Emotional intensity accompanies this process of construction. In ancestral human societies, establishing identity within a small band had direct consequences. A young adult's reputation for courage, skill, or reliability shaped access to mates and cooperative partnerships. Emotional displays signaled these qualities to others. Pride reinforced status. Shame corrected deviation. The emotional system was deeply intertwined with identity formation. By midlife, identity has typically consolidated. Careers may be established, partnerships defined, personal strengths and limitations more clearly recognized. The urgency to prove oneself diminishes because core roles are already secured. This consolidation changes the emotional landscape. Fewer experiences threaten the foundation of self-definition. When fewer events feel existential, fewer emotional spikes follow. From a developmental perspective, psychologists often describe midlife as a period oriented toward generativity rather than self-construction. The focus shifts toward contributing to others and maintaining structures already built. In ancestral settings, this shift would have been essential. Older individuals served as transmitters of culture and memory. Their authority depended less on visible dominance and more on continuity of identity. Emotional steadiness reinforced that continuity. A stable sense of self reduced the need for reactive displays. Neurobiological patterns mirror this identity consolidation. As neural pathways strengthen through repetition, responses become more predictable. Emotional reactions are filtered through established self-concepts. The brain compares new information against long-held narratives. When experiences align with expectation, the amplitude of surprise and distress decreases. This does not eliminate feeling. It embeds it within a stable framework. In early human groups, such stability would have supported mentorship. Younger members navigating uncertain identity could look to older individuals for consistency. Excessive volatility in mentors would have undermined guidance. Moderated emotional expression reinforced social trust. In modern extended lifespans, identity consolidation unfolds over a prolonged middle stage. The contrast with earlier decades becomes visible because both identity formation and identity maintenance occupy significant portions of life. When someone feels that a substantial portion of their emotional turbulence has faded after 40, they may be sensing this stabilization of self. Events no longer carry the same threat to identity. The nervous system registers fewer situations as requiring dramatic response. The evolutionary roots of this pattern reach back to small bands where identity and survival were closely linked. Once an individual's place within the group was secure, constant emotional signaling was unnecessary. Stability signaled reliability. The perception that 60% of emotional intensity has disappeared may therefore reflect a transition from identity construction to identity continuity. What fades is not the capacity to feel, but the urgency to define oneself through every interaction. In a lifespan that now extends far beyond ancestral expectations, this stabilized phase becomes a central experience rather than a brief prelude to old age. The emotional system adapts accordingly, favoring depth and coherence over fluctuation and display. Long before written records, the emotional life of human beings left indirect traces in bone, settlement patterns, and burial sites. Archaeology does not preserve feelings, yet it preserves the structures within which feelings unfolded. When researchers examine prehistoric burial grounds, they often find evidence of individuals who survived significant injury or chronic illness. Healed fractures, worn joints, and dental decay suggest that some members of early communities lived long enough to experience physical decline. Their survival implies care from others. A person unable to hunt or gather independently could only live if the group invested in their well-being. This investment indicates a social environment in which older individuals retained value. Emotional intensity tied to competition and reproductive urgency would have been less central to these roles. Stability and continuity were likely more important. Settlement patterns also revealed generational layering. In certain Paleolithic and Neolithic sites, artifacts indicate long-term occupation of specific regions. Knowledge of seasonal migration routes, water sources, and plant cycles would have accumulated over decades. Individuals who carried this knowledge across years contributed to group resilience. The transmission of such information required patience and memory. Emotional moderation would have supported clarity in storytelling and instruction. Excessive volatility might have disrupted collective learning. In small hunter-gatherer bands, where survival depended on coordination, emotional steadiness in older members likely enhanced cohesion. Anthropological parallels from contemporary foraging societies offer additional insight. Elders often function as advisors during conflict, mediating disputes between younger members. Their authority rests not on physical dominance but on experience. Emotional restraint reinforces that authority. When younger individuals react strongly to perceived threat or rivalry, the moderated presence of older members can prevent escalation. This pattern suggests that the reduction of emotional amplitude after 40 may have social utility deeply rooted in human history. The archaeological record also reflects demographic proportions. Many ancient populations had age distributions skewed toward youth. While some individuals lived into later adulthood, they were fewer relative to the young. In such a structure, the emotional climate of the group would have been shaped by youthful intensity, yet balanced by the stabilizing presence of elders. The evolutionary advantage of moderated emotional responses in later life would have been indirect but meaningful, supporting survival of kin and preservation of knowledge. In modern societies, extended middle age spans decades rather than a shorter terminal phase. The same biological and social transitions that once marked entry into elder status now occur much earlier relative to total lifespan. When someone feels that a large portion of their emotional extremes has softened after 40, they may be experiencing a shift that historically aligned with the beginning of elder contribution within small communities. Archaeology cannot measure percentage of emotion, but it reveals social structures in which emotional moderation would have been adaptive. The disappearance of sharp volatility may therefore reflect not deterioration but alignment with a long-standing human pattern. As individuals move from direct competition toward mentorship and cultural continuity, the nervous system recalibrated. What fades is the intensity optimized for youthful rivalry. What remains is the steadiness that allowed early human groups to survive across generations in unpredictable environments. When archaeologists study ancient settlement layers, they often observe continuity rather than constant upheaval. Hearths are rebuilt in the same locations. Tool-making traditions persist across generations with gradual refinement rather than radical change. This continuity suggests that knowledge was transmitted steadily over long periods. In small-scale societies, such transmission required not only memory but emotional balance. Instruction delivered through panic or volatility would have weakened learning. Calm repetition, shaped by patience, allowed skills to embed. In early human groups, individuals who reached midlife and beyond likely served as anchors of this continuity. Their emotional tone would have influenced the rhythm of daily life. Skeletal evidence from some Paleolithic sites indicates that certain older individuals survived with physical impairments that limited mobility. Survival under such conditions implies cooperative support. In a band where food acquisition was demanding, allocating resources to less physically productive members only made sense if those members contributed in other ways. Guidance, planning, and dispute resolution become plausible contributions. These roles depend on perspective. Emotional reactivity that once drove competition in youth would have been less useful in mediating between younger members. Moderation likely strengthened authority. The archaeological record also reveals ritual practices, including burials accompanied by symbolic objects. These practices imply shared belief systems and collective memory. Maintaining such systems across generations requires narrative stability. Emotional extremes can fracture shared meaning. Measured storytelling reinforces it. From an evolutionary standpoint, emotional recalibration after 40 may have supported the preservation of collective identity. In small hunter-gatherer communities, identity was not individualistic in the modern sense. It was woven into group survival. The moderated emotional responses of older members could have stabilized intergenerational bonds, reducing internal fragmentation. Demographic models of prehistoric populations show that while average life expectancy at birth was low, those who survived early childhood could sometimes live into later decades. The presence of elders, though proportionally smaller than today, was significant enough to shape group dynamics. Their emotional steadiness would have complemented the intensity of younger adults. Youth drove expansion and exploration. Age preserved memory and cohesion. In modern extended lifespans, this complementarity unfolds across a much longer time frame. Individuals spend many years in what would historically have been considered later adulthood. When contemporary people sense that a large portion of their emotional volatility has diminished after 40, they may be entering a phase that once aligned with elderhood in small bands. The nervous system softens peaks not because it is failing, but because its role has shifted. Archaeology cannot tell us how intensely someone felt, but it reveals social patterns in which emotional moderation would have been adaptive. The disappearance of sharp emotional spikes may therefore echo an ancient transition from direct competition to cultural stewardship. In a species whose survival depended on both youthful drive and mature stability, the softening of emotional extremes after 40 reflects a deep continuity. It connects modern midlife not only to biology, but to the long arc of human communities that relied on balance between intensity and endurance. If we look not only at bones and tools, but at spatial organization in ancient sites, another pattern emerges. Campsites and early settlements were structured around shared spaces, central hearths, communal work areas, and gathering points. These were not merely physical arrangements, they were emotional environments. Life unfolded in close proximity. Disputes, alliances, courtship, and cooperation all took place within view of others. In such tight social architecture, unregulated emotional volatility could destabilize the entire group. Emotional moderation in older members likely served as a stabilizing force within these shared spaces. Anthropological research among contemporary hunter-gatherer societies suggests that older adults often influence group decisions without formal authority. Their guidance rests on reputation built over time. Reputation, in turn, depends on consistency. A person known for measured response gains trust. In a world without written law or centralized institutions, trust was the core infrastructure of survival. Emotional steadiness contributed directly to that infrastructure. Younger members, whose reproductive stakes were higher, might display stronger reactions to competition or perceived injustice. The presence of older individuals who did not escalate every conflict would have reduced fragmentation. Archaeological patterns of long-term site occupation imply that many groups returned repeatedly to the same locations. Continuity in space reflects continuity in social bonds. For such bonds to endure across seasons and generations, emotional climates needed balance. High-intensity rivalry without counterweight could fracture cooperation essential for hunting, gathering, and child-rearing. The reduction in emotional amplitude after 40 may therefore echo a structural need embedded in early human settlement. From a demographic perspective, the relative scarcity of older individuals in prehistoric populations increased their symbolic value. Their survival itself signaled resilience. In environments where life was uncertain, reaching later adulthood marked accumulated experience. Emotional moderation may have reinforced the perception of wisdom. In modern societies, where reaching 40 or 50 is common, this symbolic distinction has blurred. Yet the internal biological and social shift persists. The nervous system recalibrates even when the demographic context has changed. When someone today feels that a significant portion of their emotional extremes has softened, they may be aligning with a pattern that historically signaled entry into a stabilizing role within the group. Archaeology does not record inner states, but it reveals structures that required balance. Central hearths imply shared narratives. Repeated tool forms imply transmitted skill. Sustained occupation implies cooperation. Emotional moderation in older members would have supported all three. The idea that 60% of emotion disappears after 40 can be reframed through this lens. What fades is the intensity suited for rapid competition within a youthful cohort. What emerges is steadiness suited for maintaining shared space. In the deep past, this transition occurred within communities that depended on emotional balance for survival. In the present, it unfolds within far larger societies, yet the underlying neural trajectory remains. The softening of extremes after 40 may not be a sign of decline. It may be the echo of an ancient spatial and social architecture, in which maturity meant becoming an anchor rather than a spark within the human group. The modern world presents a paradox. Human lifespans have expanded dramatically over the past 2 centuries, yet the emotional system operating within those longer lives remains ancient. Cities, digital communication, financial markets, and global networks create constant streams of stimulation. News cycles deliver threat signals from distant regions. Social media amplifies comparison and status cues far beyond the scale of a small ancestral band. From a biological perspective, however, the nervous system still processes these signals using circuits shaped in open landscapes and close-knit groups. In early human environments, the number of daily emotional triggers was limited by physical proximity. A person encountered only those individuals within their immediate group and perhaps neighboring bands. Threats were concrete and local. Competition was visible and bounded. Emotional spikes, while intense, were episodic. Between those spikes, there were long stretches of routine activity shaped by natural rhythms of daylight and season. After 40 in modern society, the internal recalibration toward moderation collides with an environment that continues to generate high-volume stimulation. Hormonal shifts, strengthened prefrontal regulation, and accumulated memory reduce the amplitude of emotional response. Yet, external signals remain loud. This mismatch can create a subjective sense that something inside has dulled while the outside has intensified. In ancestral contexts, reaching midlife often coincided with a narrowing of direct competition. The number of daily triggers naturally decreased as social roles stabilized. Today, competition may persist in professional and digital arenas well beyond peak reproductive years. The emotional system, however, continues its gradual shift toward conservation. Research in cognitive aging suggests that older adults often show improved capacity to filter irrelevant stimuli. Selective attention becomes more deliberate. This filtering can feel like emotional dampening when compared to the heightened sensitivity of youth. Yet it may represent adaptation to overwhelming informational environments. The brain reduces reactivity not because it is incapable, but because constant amplification would be metabolically unsustainable. In small hunter-gatherer groups, the balance between stimulus and response was relatively proportional. In modern societies, stimulus frequency has increased without a parallel increase in biological capacity for sustained arousal. After 40, As stress systems recalibrate and reward sensitivity moderates, the nervous system may become less responsive to rapid cycles of novelty, and outrage. This reduction can be misinterpreted as emotional disappearance. In reality, it may protect long-term stability. From an evolutionary perspective, the emotional system was designed to oscillate between activation and rest within predictable environmental rhythms. Extended middle age in contemporary life stretches this oscillation across decades of high-density stimulation. The sensation that 60% of emotional intensity has faded may reflect the brain's attempt to regulate itself within this amplified context. Rather than remaining in constant urgency, it prioritizes sustainability. The ancient circuitry that once balanced survival threats on open plains now navigates abstract pressures transmitted through screens. After 40, the internal recalibration towards steadiness becomes more visible against this modern backdrop. What appears to be loss may be the nervous system's effort to remain coherent in an environment that far exceeds the scale for which it was originally shaped. In modern life, stimulation does not only increase in quantity, it changes in character. Many of the signals that activate emotional circuits today are symbolic rather than immediate. Financial uncertainty, professional reputation, digital comparison, and global events all trigger neural pathways originally tuned for physical survival within small groups. The amygdala does not distinguish clearly between a predator at the edge of a clearing and a threatening headline on a screen. It responds to perceived relevance. In youth, when hormonal systems amplify reward and threat sensitivity, these symbolic cues can generate strong emotional swings. After 40, as endocrine levels shift and regulatory networks strengthen, the brain often becomes less reactive to repeated abstract signals. This moderation can feel like emotional fading when compared to earlier years, yet it may represent recalibration to an environment saturated with indirect stimuli. In ancestral settings, emotional activation was followed by resolution. A confrontation either ended in reconciliation or separation. A hunt succeeded or failed. A threat was escaped or endured. The nervous system completed its cycle. In modern environments, many stresses remain unresolved. News cycles continue. Economic pressures persist. Digital interactions rarely provide closure. Continuous partial activation without clear resolution can exhaust emotional systems. Over time, the brain may dampen responsiveness to prevent chronic overactivation. This dampening is not indifference. It is protective adaptation. Studies in stress physiology suggest that prolonged exposure to high arousal cues without physical discharge can alter stress reactivity patterns. The body seeks equilibrium. After decades of exposure, especially by midlife, the nervous system may reduce the amplitude of response to preserve long-term stability. From an evolutionary perspective, this shift would not have been as necessary in small hunter-gatherer groups where stimuli were episodic and tied to concrete events. Emotional systems evolved within cycles of activation and rest embedded in natural rhythms. The modern environment disrupts those rhythms. Artificial lighting, constant connectivity, and abstract social hierarchies extend activation beyond ancestral norms. When individuals reach 40 and notice that their emotional extremes have softened, they may be observing the cumulative effect of years spent adapting to this mismatch. The brain gradually prioritizes endurance over excitement. Reward sensitivity may decrease not only because of hormonal change, but because repeated stimulation reduces novelty. Dopamine circuits respond most strongly to new and unpredictable rewards. In environments where novelty is constant, the threshold for excitement rises. What once felt intense may now feel ordinary. This phenomenon aligns with research showing that reward responsiveness can decline with age, especially when exposure to stimulation is high. In early human history, novelty was rare and often consequential. Emotional peaks were proportionate to environmental change. In modern life, novelty is manufactured daily. The nervous system, shaped by scarcity of stimulus, adapts by filtering and moderating. The perception that 60% of emotional intensity has disappeared may therefore reflect long-term adaptation to overstimulation combined with biological recalibration after peak reproductive years. Rather than indicating emptiness, this moderation may allow sustained engagement across extended lifespans. It is a quiet negotiation between ancient circuitry and modern context, unfolding gradually as individuals move deeper into middle age within an environment vastly different from the one in which the emotional system first evolved. There is another tension between the ancient emotional system and the modern environment that becomes clearer after 40. In early human history, social comparison occurred within a narrow circle. A person measured themselves against perhaps a few dozen individuals. Status signals were direct and observable. Hunting skill, physical endurance, generosity, reliability. Emotional reactions to status change were intense because they affected immediate survival, yet the scale was limited. One could see the entire field of comparison. In modern societies, comparison is global. Digital platforms expose individuals to thousands of curated lives. Economic hierarchies are vast and abstract. Professional recognition may depend on distant evaluation rather than on visible contribution within a small group. For younger adults whose neural systems are primed for status competition, this expanded comparison field can amplify emotional volatility. After 40, as hormonal drives moderate and regulatory circuits strengthen, the brain may begin to withdraw from constant comparison. Research in lifespan psychology often shows that older adults report reduced concern with external status markers and greater focus on intrinsic goals. This motivational shift dampens emotional spikes tied to social evaluation. The brain allocates fewer resources to monitoring every fluctuation in public perception. In ancestral bands, by midlife, individuals often held established positions within the group. Their status was relatively stable. Constant renegotiation was unnecessary. Emotional moderation reflected this stability. In modern life, although status systems remain active, the internal urgency to track them may decline. The nervous system, shaped by evolution to monitor small-scale hierarchies, becomes less responsive to the endless expansion of modern comparison. This recalibration can feel like emotional reduction, yet it may represent a protective narrowing of focus. There is also the dimension of time perception. Younger adults often experience time as expansive. Future possibilities appear numerous. Emotional investment in each opportunity feels high because it may define decades ahead. After 40, perception of time subtly changes. The remaining future, while still substantial, is experienced as more finite. Psychological research suggests that as perceived time horizon shortens, motivational priorities shift toward emotional meaning rather than exploration. This shift reduces the intensity of reactions to abstract future gains and losses. The brain invests in present stability rather than distant expansion. In early human environments, such a shift would have aligned with life stages approaching elder roles. Emotional resources were directed toward preserving kin and transmitting knowledge rather than toward personal advancement. In modern extended lifespans, this temporal recalibration occurs while many decades remain. The contrast between external expectations of continued ambition and internal movement toward meaning can create confusion. When someone senses that 60% of their emotional intensity has faded after 40, they may be encountering this convergence of reduced status monitoring, selective comparison, and altered time perception. The ancient circuitry that once amplified competition in youth gradually reorients towards stability and significance. Within the deep history of our species, this reorientation marked entry into a phase of continuity. Today it unfolds within a world saturated with endless signals. The emotional system does not collapse. It adjusts its focus, narrowing from global comparison to meaningful connection, from endless possibility to coherent direction. What appears as disappearance may be the brain's quiet refusal to remain in perpetual competition within an environment far larger and louder than the one for which it was originally designed. When people describe that a large portion of their emotions disappears after 40, the word loss often carries quiet concern. It suggests something missing, something that once made life vivid. Yet the experience of reduced volatility does not automatically imply diminished depth. To understand this distinction, it helps to separate emotional intensity from emotional meaning. Intensity refers to amplitude, the height of peaks and depth of valleys. Meaning refers to integration, the extent to which feelings connect to memory, values, and long-term narrative. In early adulthood, intensity often dominates awareness. Emotional reactions are strong and immediate because they signal rapid shifts in identity, status, and opportunity. In ancestral human environments, these rapid shifts were common. A successful hunt, a failed alliance, or a territorial dispute could alter survival prospects quickly. The emotional system amplified these events to ensure learning and adaptation. High amplitude made sense in volatile conditions. After 40, many foundational structures have stabilized. Identity is more defined. Relationships are more established. Resources are less frequently renegotiated from zero. The nervous system, shaped by accumulated experience, begins to rely more on interpretation than on raw surge. Neurobiological studies suggest that while reactivity to certain negative stimuli decreases with age, connectivity in regions associated with reflection and autobiographical processing remains active. Emotional events are less likely to feel overwhelming, but they may be woven more deeply into personal narrative. This shift from intensity to integration can be misinterpreted as emotional reduction. In evolutionary terms, the distinction is important. Youthful intensity supported immediate adaptation within small bands. Mature integration supported continuity across generations. An older individual recounting a difficult season did not need to relive its panic at full amplitude. They needed to transmit its lesson clearly. Emotional moderation enhanced clarity. In modern society, where expressive intensity is often associated with authenticity, the reduction of volatility may feel like dullness. Yet research in lifespan psychology frequently finds that overall life satisfaction does not decline in midlife. Many individuals report increased emotional stability and resilience. They may experience fewer extreme highs, but also fewer destabilizing lows. The baseline becomes steadier. From the perspective of early human survival, this steadiness would have conserved energy and reduced intragroup conflict. Emotional extremes, while adaptive in youth, can fracture cooperation when sustained. After reproductive urgency diminishes, the evolutionary advantage shifts toward maintaining group cohesion. The nervous system appears to reflect this shift. When someone senses that 60% of their emotional turbulence has softened, they may be noticing the transition from amplitude to coherence. The peaks are lower, but the terrain is more navigable. What once felt like storms may now feel like currents. In a lifespan extended far beyond ancestral expectations, this transition occupies a substantial chapter. The contrast with earlier decades can create the illusion of disappearance. Yet the emotional system remains active, shaped by ancient pressures that favored intensity during competition and stability during continuity. The question becomes not whether emotion has vanished, but whether its form has evolved from dramatic display to sustained meaning within a life that now stretches across far more years than the original evolutionary script anticipated. One of the most common misunderstandings about emotional change after 40 is the assumption that fewer visible reactions mean fewer internal processes. In reality, many emotional operations become more internalized with age. Younger adults often express emotion outwardly because identity and status are still being negotiated. Displays of enthusiasm, frustration, or disappointment communicate position within the group. In ancestral bands, visible signals mattered. They shaped alliances and deterred rivals. Emotional expression was part of social negotiation. By midlife, however, social position is often more stable. The need to signal every fluctuation diminishes. The emotional system may still generate feeling, yet the expression becomes measured. This internalization can be misread as reduction. Neuropsychological research suggests that while older adults may show decreased physiological arousal in response to certain stimuli, they often maintain the capacity for emotional comprehension and empathy. In some domains, perspective taking improves with age due to accumulated social experience. Emotional intelligence becomes less about reacting and more about interpreting. This shift reflects not disappearance but refinement. From an evolutionary standpoint, refinement would have enhanced group survival. In small human communities, individuals who survived into later adulthood had likely witnessed multiple cycles of scarcity, conflict, and reconciliation. Their emotional reactions were informed by pattern recognition. Instead of responding to each provocation with intensity, they could evaluate its broader significance. This evaluation reduced unnecessary escalation, Emotional energy was conserved for events that truly required intervention. Another dimension involves resilience. Research in developmental psychology often finds that middle-aged and older adults report fewer episodes of prolonged negative affect following stressors. Recovery becomes more efficient. The emotional system does not avoid pain, but it exits pain more quickly. In early human settings, such resilience would have been valuable. Prolonged distress could impair participation in group tasks, essential for survival. Moderation allowed individuals to remain functional even in difficult conditions. In modern extended lifespans, resilience after 40 may manifest as quicker emotional stabilization following disappointment or conflict. What once triggered days of rumination may now settle within hours. This can feel like diminished intensity, yet it represents enhanced regulation. There is also a motivational shift toward emotionally meaningful experiences. As perceived time horizons change, individuals often prioritize close relationships and personally significant goals. Emotional investment narrows but deepens. The frequency of high-amplitude events decreases because attention is directed toward fewer domains. In ancestral communities, focusing on close kin and trusted allies in later adulthood would have strengthened group cohesion. Emotional moderation supported this focus. When someone reflects that 60% of their emotions seem to have disappeared after 40, they may be noticing fewer dramatic oscillations rather than fewer feelings. The nervous system becomes selective. It reacts strongly only when events align with core values or close bonds. Peripheral stimuli lose their power to provoke intense response. Within the long arc of human evolution, such selectivity would have marked the transition from expansion to stewardship. The emotional system narrows its spotlight, conserving energy and reinforcing stability. What appears as emptiness may instead be concentration, a quieter form of emotional life shaped by decades of integration and by an evolutionary history in which maturity meant guiding rather than competing. There is a final layer to reconsider when speaking about emotional disappearance, after 40, and it concerns comparison with memory rather than with biology. When individuals look back on earlier decades, memory often preserves emotional peaks more vividly than emotional baselines. Neuroscience shows that high arousal events are encoded more strongly in episodic memory. The intensity of first love, early career achievement, or painful rejection becomes anchored as defining moments. Routine calmness, by contrast, leaves lighter traces. As a result, recollection of youth can feel saturated with intensity even if daily life at the time included long periods of ordinariness. This memory bias shapes present perception. After 40, when emotional responses become more regulated and less extreme, the contrast with remembered peaks can exaggerate the sense of loss. It may appear that a large percentage of emotion has vanished, when in fact what has changed is the frequency of high arousal moments rather than the presence of feeling itself. In early human societies, such peaks would have coincided with major survival events, successful hunts, territorial disputes, alliance formation. These were memorable because they carried consequence. Yet the majority of days likely unfolded in routine activity shaped by environmental rhythms. Memory compresses time, highlighting drama and overlooking steadiness. The same compression occurs in modern reflection. Middle-aged adults compare present equilibrium with remembered intensity and interpret the difference as reduction. From a psychological perspective, this is not decline but recalibration. Emotional regulation improves across adulthood. Recovery from stress becomes faster. Attention shifts toward meaningful domains. These changes lower the amplitude of daily fluctuation. At the same time, depth may increase. Emotional experiences become layered with context, informed by decades of accumulated narrative. The nervous system prioritizes coherence over novelty. In evolutionary terms, this shift aligns with the transition from direct competition to cultural continuity. In small hunter-gatherer bands, older individuals were unlikely to seek constant emotional peaks. Their role emphasized reliability and guidance. The moderated emotional landscape supported group survival across seasons. When modern individuals sense that 60% of their emotional intensity has disappeared, they may be encountering the difference between remembered peaks and present stability. The body and brain have not eliminated feeling, they have altered amplitude and interpretation. What remains may be less dramatic but more enduring: the quiet satisfaction of stability, the measured response to conflict, the capacity to hold mixed emotions without fragmentation. These qualities do not announce themselves as vividly as youthful extremes, yet they reflect a nervous system adapted for longevity rather than urgency. In a lifespan now extended far beyond ancestral norms, this moderated phase occupies decades. The illusion of disappearance arises because memory favors contrast. Beneath that illusion, the emotional system continues to function, shaped by ancient pressures and modern context alike. The question is not how much has vanished, but how perception has shifted in relation to memory, biology, and the long arc of human development. If emotional intensity softens after 40, it is worth asking what remains in its place. The absence of sharp peaks does not leave emptiness. It often reveals a different emotional texture, one less volatile but more sustained. Research in lifespan psychology consistently shows that many adults in midlife report greater overall emotional stability compared to earlier decades. They may experience fewer extreme highs and lows, yet they often describe a deeper sense of contentment or balance. This pattern suggests that while amplitude decreases, baseline well-being can remain steady or even improve. In early human environments, such steadiness would have carried adaptive value. Survival within small bands required coordination over long stretches of time. Individuals who could maintain consistent cooperation without frequent emotional escalation supported group resilience. After peak reproductive years, the evolutionary emphasis shifted from expansion to continuity. Emotional moderation facilitated this shift. Instead of reacting to every fluctuation in status or opportunity, the nervous system favored equilibrium. One emotional quality that often strengthens after 40 is acceptance. Acceptance does not mean resignation. It refers to the ability to acknowledge difficulty without immediate resistance. Neuroimaging studies suggest that older adults may engage regulatory networks more effectively when processing negative stimuli. This engagement reduces rumination and supports faster recovery. In ancestral contexts, prolonged rumination would have impaired participation in essential tasks such as foraging, toolmaking, or childcare. Emotional efficiency conserved energy. Another quality that often persists or deepens is empathy grounded in experience. Decades of social interaction provide a rich archive of patterns. When confronted with another person's distress, a middle-aged individual may respond with perspective shaped by memory rather than with reactive urgency. This perspective does not eliminate compassion, it stabilizes it. In small hunter-gatherer groups, such stability would have strengthened social bonds across generations. Emotional life after 40 also frequently includes increased valuation of meaning. Studies examining motivational priorities indicate that as perceived time horizons shorten, individuals focus more on emotionally meaningful activities and relationships. The pursuit of novelty for its own sake may decline, but the depth of engagement within chosen domains can intensify. In evolutionary terms, this narrowing of focus would have reinforced kinship ties and cultural continuity. Emotional energy was invested where it most benefited group survival. When someone reflects that 60% of their emotional intensity has faded, they may be observing the reduction of volatility rather than the loss of core feeling. What remains is steadiness, perspective, and selective investment. The nervous system shifts from amplifying every stimulus to highlighting what aligns with long-term values. In a lifespan that now extends far beyond ancestral expectations, this phase becomes highly visible. It can be misinterpreted as dullness in a culture that equates excitement with vitality. Yet, from a biological and historical standpoint, the qualities that endure after 40 stability, empathy informed by memory, and focus on meaning mirror roles that sustained human communities for thousands of years. Emotional life does not disappear. It reorganizes around continuity rather than competition, around endurance rather than display. Another quality that often becomes more visible after 40 is patience. In early adulthood, impatience is closely tied to opportunity. When the future feels expansive and uncertain, waiting can feel costly. Every decision appears capable of altering long-term trajectory. Emotional urgency reinforces rapid movement. In ancestral human settings, this urgency had clear adaptive value. Securing mates, establishing alliances, and responding to environmental shifts required speed. Emotional intensity supported swift action in conditions where delay could reduce survival chances. By midlife, however, accumulated experience changes the calculus of time. Many goals have already been achieved or redefined. Patterns of success and failure have repeated enough to reveal their cycles. The nervous system begins to recognize that not every setback carries permanent consequence. Patience becomes easier not because desire disappears, but because perspective expands. Neurobiological studies suggest that with age, individuals often display improved impulse control and reduced sensitivity to immediate reward. This change is linked to alterations in dopamine signaling and strengthened regulatory circuits. The result is not emotional absence, but emotional pacing. Reactions unfold more slowly. Decisions incorporate broader context. In small hunter-gatherer communities, such pacing would have contributed to long-term stability. An elder who responded to scarcity with measured strategy rather than panic could prevent fragmentation. Patience conserved collective energy. Alongside patience, gratitude frequently deepens in midlife. As the perception of time shifts and novelty decreases, familiar experiences can take on renewed significance. Research in positive psychology indicates that older adults often report heightened appreciation for close relationships and ordinary routines. This appreciation is less dramatic than youthful exhilaration, yet it is steady. In ancestral contexts, steady appreciation of kin and shared resources would have reinforced cooperation. Emotional investment in daily continuity strengthened group cohesion across seasons. There is also evidence that middle-aged and older adults become more selective in emotional exposure. They may avoid unnecessary conflict or disengage from interactions that consistently provoke distress. This selectivity reduces the number of triggers for extreme reaction. The emotional system narrows its focus to domains aligned with personal values. From an evolutionary perspective, this narrowing supports efficient resource allocation. In later life stages within small bands, energy invested in stable kin networks would have had greater survival payoff than energy spent on distant rivalries. When individuals sense that a large portion of their emotional volatility is diminished after 40, they may be experiencing the emergence of these quieter qualities. Patience replaces urgency. Gratitude replaces novelty seeking. Selectivity replaces broad comparison. None of these changes eliminate feeling. They reshape its distribution. In a world that often equates intensity with authenticity, such reshaping can be misinterpreted as reduction. Yet across the long arc of human history, these traits supported continuity and resilience. Emotional life after 40 may appear less dramatic, but it can become more intentional. The amplitude narrows, yet the direction clarifies. What remains is not emptiness but refinement, a reorientation of feeling toward endurance, connection, and meaning within a lifespan that now extends far beyond the boundaries our ancestors typically experienced. As the emotional landscape settles after 40, another subtle transformation often becomes visible: the widening capacity to hold complexity without fragmentation. In early adulthood, emotional experiences can feel binary: success or failure, acceptance or rejection, love or loss. The nervous system, primed for rapid action and status negotiation, tends to amplify contrasts. Clear distinctions support quick decisions. In ancestral human groups, such decisiveness was adaptive. Ambiguity during threat or rivalry could delay response and increase risk. Emotional intensity simplified interpretation, narrowing focus to immediate priorities. By midlife, accumulated experience introduces nuance. Individuals have encountered conflicting outcomes, mixed motives, and repeated cycles of change. The brain, shaped by decades of pattern recognition, becomes more comfortable with ambiguity. Neuropsychological research suggests that older adults often demonstrate improved integration of emotional information, tolerating contradictory feelings simultaneously. Joy and regret can coexist. Pride and humility can share space. This capacity reflects strengthened communication between cognitive and emotional networks. Rather than reacting to each stimulus as isolated, the brain situates it within a broader framework. From an evolutionary standpoint, this tolerance of complexity would have supported group stability. In small hunter-gatherer communities, disputes rarely involved simple narratives. Alliances overlapped with kinship ties. Resource scarcity affected multiple households. An elder who could navigate layered social dynamics without escalating conflict would have preserved cohesion. Emotional moderation allowed space for dialogue rather than immediate reaction. The modern perception that 60% of emotional intensity has disappeared may therefore conceal the emergence of this integrative capacity. The absence of sharp extremes creates room for layered interpretation. Emotional life becomes less about immediate dominance of one feeling and more about sustained balance among several. Research in lifespan development often finds that middle-aged and older adults show reduced susceptibility to certain forms of cognitive bias linked to emotional reactivity. They may be less prone to overgeneralizing from single negative events. This stability is not indifference, it is perspective. In early human environments, perspective supported survival across unpredictable seasons. Panic in response to temporary scarcity could fragment cooperation. Measured appraisal maintained collective effort. In modern extended lifespans, the integrative quality of emotion may feel quieter because it lacks dramatic peaks, yet it supports endurance across decades of responsibility and change. Emotional experience becomes less about proving identity and more about sustaining it. The nervous system no longer treats every challenge as existential. Instead, it differentiates between transient disturbance and meaningful shift. This differentiation reduces volatility. It also enhances resilience. What appears to have vanished after 40 may be the tendency to interpret each event as defining. What remains is the capacity to situate events within a larger arc. In a lifespan that now stretches far beyond ancestral norms, this arc grows long. Emotional life adapts accordingly, favoring integration over amplification. The disappearance of extremes is not the disappearance of feeling. It is the quiet expansion of emotional range into complexity, shaped by memory, regulation, and the deep evolutionary patterns that once balanced youthful urgency with mature steadiness within small human communities. When we reach the final stage of this exploration, the question shifts from disappearance to transformation. If emotional intensity softens after 40, perhaps the more precise inquiry is not how much has vanished, but what the system is preparing for. In early human history, survival required alternating phases of urgency and endurance. Youth emphasized expansion, reproduction, and rapid adaptation. Later adulthood emphasized preservation, teaching, and long-term cohesion. Emotional systems mirrored these phases. High amplitude served competition and exploration. Moderation served continuity. In modern extended lifespans, these phases stretch across far more years than they once did. What was historically a brief transition into elder status now occupies decades of middle age. The nervous system continues to follow ancient rhythms even as the calendar extends. The perception that 60% of emotion disappears after 40 may reflect entry into a different operational mode rather than decline. In this mode, intensity yields to sustainability. The brain conserves metabolic energy. Hormonal systems stabilize. Regulatory networks strengthen. Attention narrows toward meaningful domains. The result can feel quieter. Yet, quiet does not mean empty. From an evolutionary perspective, quiet may signal readiness for stewardship. In small hunter-gatherer bands, individuals who survived into later adulthood carried responsibility for transmitting knowledge and stabilizing conflict. Their emotional steadiness allowed them to interpret events across longer timelines. In modern life, stewardship may take different forms, guiding younger colleagues, supporting family continuity, maintaining social networks, but the underlying shift remains. Emotional life becomes less about proving vitality and more about sustaining direction. There is also a broader biological frame to consider. Aging involves gradual changes in energy allocation throughout the body. Maintenance and repair processes become more central. Systems that once favored rapid expansion reorient toward balance. The brain participates in this redistribution. Emotional amplitude may narrow as part of a coordinated strategy to support long-term coherence. Research consistently shows that many individuals maintain or even increase overall life satisfaction across midlife, despite experiencing fewer dramatic emotional swings. Stability becomes the new signal of health. In a culture that equates excitement with aliveness, this stability can be misread. Yet within the long arc of human evolution, it may represent maturity aligned with ancient social architecture. The emotional system, shaped in small communities under uncertain conditions, adapts when the urgent phase concludes. What fades is not the capacity to feel, but the evolutionary necessity for constant escalation. As the lifespan extends far beyond ancestral expectations, this moderated state spans decades. The question that remains is not whether emotion disappears, but whether we are willing to recognize transformation when it unfolds quietly. If the storms of youth recede and are replaced by steady currents, is that reduction or refinement? And when we ask why 60% of our emotions seem to disappear after 40, are we measuring loss or witnessing a shift that our species has carried within it since the beginning? As this shift unfolds across midlife, it invites a different way of interpreting emotional quietness. In youth, emotion often feels like propulsion. It pushes decisions forward. It accelerates attachment, ambition, rivalry, and escape. The body responds with surges of chemistry designed for action. In ancestral environments, such propulsion was adaptive during a limited window when survival and reproduction were most urgent. After that window, however, propulsion alone was not enough. Human groups depended on memory, continuity, and intergenerational coordination. Emotional life gradually reorganized to support these demands. The softening of extremes after 40 may therefore represent entry into a longer arc of integration. Rather than chasing every stimulus, the nervous system begins to discriminate more carefully. It invests energy where consequence is real, and withdraws from constant activation where consequence is abstract. This discrimination reflects accumulated experience. Decades of pattern recognition allow the brain to anticipate outcomes with greater accuracy. When prediction improves, surprise diminishes. When surprise diminishes, intensity often follows. This is not a sign of detachment from life. It is evidence of calibration. In early human history, calibration would have reduced unnecessary conflict within small bands. An elder who reacted to every minor tension with youthful force could destabilize fragile cooperation. Moderation became adaptive because it preserved long-term alignment. Modern society, with its vast networks and persistent stimulation, rarely signals when escalation is truly necessary. The brain must infer this threshold. After 40, strengthened regulatory systems and hormonal stabilization help maintain coherence in the face of noise. Emotional energy is conserved for relationships and responsibilities that endure. Research in lifespan development frequently shows that emotional goals shift toward intimacy and meaning as perceived time horizons change. This shift does not eliminate ambition, but it reframes it. The pursuit of external validation becomes less urgent than the cultivation of stable connection. In evolutionary terms, this reframing echoes the transition from expansion to stewardship within early communities. The emotional system was never designed to remain in a constant state of youthful propulsion for 7 or 8 decades. It was shaped for a compressed timeline. As lifespans extended, the moderated phase expanded accordingly. When someone senses that 60% of their emotional intensity has faded after 40, they may be experiencing this expansion of moderation. What once felt like a dramatic arc now feels like a steady current. The question is whether that current carries less vitality or simply a different form of strength. In the long story of our species, survival required both surge and steadiness. Youth embodied the surge. Maturity embodied the steadiness. The disappearance of extremes may therefore signal not emptiness but transition. A transition from reacting to shaping, from competing to sustaining, from proving to guiding. And if this transition has always been embedded in our biology, unfolding quietly after the urgent years, what might it reveal about the true design of emotional life across a lifespan that now extends far beyond the one our ancestors could have imagined? If we follow this arc to its quiet end, the question no longer asks what has been lost, but what has been revealed. Youthful emotion burns brightly because it must. It carves identity, secures alliance, pursues reproduction, and reacts to uncertainty in a world where hesitation once carried danger. That intensity is real. It is biological. It is ancient. Yet it was never meant to remain at full amplitude for a lifetime that now stretches toward 8 or 9 decades. The human emotional system was shaped in small bands moving across unpredictable landscapes, where a compressed window of urgency defined survival. Beyond that window, a different quality of life emerged. One less dramatic, yet no less essential. After 40, when hormonal surges soften and regulatory networks strengthen, the nervous system does not empty. It reorganizes. The sharp edges that once defined experience gradually smooth. Fear becomes caution. Anger becomes discernment. Desire becomes commitment. The emotional spectrum narrows in amplitude, but deepens in continuity. What feels like a reduction in intensity may be a widening of perspective. Events no longer demand existential reaction. They are absorbed into a longer narrative. Across human history, individuals who survived beyond peak reproductive years carried the burden of memory. They remembered droughts and migrations, alliances and losses. Their value lay not in the force of their reaction, but in the steadiness of their interpretation. Emotional moderation allowed them to guide rather than compete. In modern extended lifespans, this moderated phase now occupies decades. It may feel unfamiliar because culture often celebrates urgency and spectacle. Yet, biology continues to follow older rhythms. The phrase that 60% of emotion disappears after 40 is not a literal measure. It is a metaphor for transition. What diminishes is volatility. What remains is durability. The storms that once signaled expansion quiet into currents that support endurance. Life does not become less meaningful. It becomes less reactive. In the absence of constant peaks, subtler forms of satisfaction can emerge. Stability in relationships, patience in conflict, acceptance of imperfection, gratitude for continuity. These are not dramatic emotions. They are sustaining ones. If the early decades of life are shaped by acceleration, the later decades may be shaped by coherence. The emotional system, forged in environments of scarcity and risk, adapts when urgency fades. It conserves energy. It filters noise. It invests in what endures. In doing so, it mirrors patterns that have accompanied our species since its beginning. So perhaps the question is not why 60% of your emotions disappear after 40, but whether what seems to vanish was ever meant to stay. If intensity defines survival in youth, what defines maturity in a lifespan that now extends far beyond the one our ancestors expected? And when the emotional storms grow quieter, are we losing something or finally arriving at the form of balance our biology has been preparing for all along?